Hello everyone. Now I'll show you what I'm going to teach in this video. As you can see on the screen, whatever I'm saying is getting transcribed. This is because of a model which is running in the background locally on the system. And as you can see, this is real-time transcription. In other words, we can say it is a speech recognition system. And I'll show you how to train the model from scratch, from data preparation till data processing. How do we do augmentations, and what are the models, what kind of models in current industry we use, and basically how you can deploy that also. But I don't think all of that will get covered up in this video, only one video. So I'll start from data processing, and then we'll slowly go into the training. Let's get started. I have created a project here. Now I need to download the repository Icefall, and it has multiple models. In current scenario, we are going to use a model called Zipformer. That's based on transformer architecture. And let me download it first. I'll show you how to download and everything. So let's use git. I'm in the project directory. I'll clone the repo here. Download is completed. If you open the folder, here you will get a folder called ECS. In ECS you will find many different repos. So these are basically datasets which are getting used to train the models. They have done multiple experiments. Usually we use LibriSpeech. That's a very large dataset. So in ASR, if you go into the ASR folder, here you will find multiple folders. These are different kind of models. Ignore all of those, just go into the Zipformer folder, and in Zipformer you need to open the script train.py. So this is the script which we are going to use to train the model. This has like all the settings which you need. These are like default settings. If you don't need to change anything for now. If you want to deep dive into the model structure and depending on a data set also, you can change different parameters, but for now you can keep everything as default. So here if you see, it is loading the training data, and these are the training cuts. These are getting loaded here in these functions, and there are different functions to load different kind of data sets. This function is for loading different 3 different data sets. All are in one function. 100, 360 and 500. These are the data duration in hours. If you open this, if you go into this function, it has one cut zip file. It is in the manifest directory. I'll go into this, and you need to change all of this later on. This is in ASR data module. I'll open this as well. Okay, let's download the dataset and start from there. This is the OpenSLR website. Here you'll find the different data sets. You need to go to the resources folder. Here you search for English, and if you go down, English speech recognition corpus, there are multiple speech recognition corpus. This is the 1000 LibriSpeech, which directory we are in right now. This has 100 hours of data set in English. If you click on this, you will find different sets. These are this is the validation set, and this is the 100-hour data set, clean data set. You can download this 100 hours data set. If you want all of the data, then you can download 500, 360, 100, all of this. Let me grab the 100-hour data set from here. Yeah, so I have downloaded the dataset here. This is the zip file that I have downloaded, and I have extracted out the dataset as well. I'll show you. This is the folder, and this is the folder structure. It has different sub directories, and inside all the directories there are audio files. These audio files along with the transcription, and I'll open it in VS Code. Yeah, so this transcript file contains the name, audio name, and their corresponding text, and these are space separated. So you need to process this transcript files and then format it to a manifest. Let me go into this folder first. Before that, I need to copy the path, and then let's go into the folder. Let's prepare a script like prepare manifest .py. So here in the script we need to open this folder. So let's say root directory. We'll take the root directory, and we need to import OS also. Then we need to iterate over the directories inside this folder. Let's use the for loop, root directory and files in os.work. So this work function will go into all the subfolders inside the directory, and let's print the root here if you want to see what is happening here. Let's do ls here, and this is the folder. Okay, so you need to give the path of the folder. Here the raw folder is there. Okay, if you save this and if you run this, sorry, python 3 prepare manifest. So as you can see, it has printed multiple folders, and all are like subfolders of this raw directory, and so these folders contains different files. Okay, so if you want to see the files and then be inside the root directory, then you need to use one more for loop. Let's say for directories in os dot list directory, and you use the root folder here, and then print this directories. And if you run it again, I'm sorry, this would not be directories. I think these will be files. Let's say file. Okay. And if you run this again, then you will get all the files inside it, all the audio files as well as the text file. But here we need to ignore the audio files. We will just use the text files. And if you in this directory, if you see, this is the root directory, and inside that the files are there. So we can use this root to concatenate with the transcript. So here we need to use this transcript file. So let's say if .txt is in the file, then we know that that's a transcript file. So here we need to open the transcript for line in open. Let's open it, but to open it we need to join the path root and file os.path.join, and here we need to join root and file. So this will open the transcript file. You need to read the lines. This read lines function will read it, and here you can print the line here. Okay, let's save it and run it once. Let's see. So here if you see, it has printed multiple lines. These are the lines, transcript lines, as well as their corresponding audio names. Okay, so let's see here. What we need to do is we need to take the line, and each line has one ID, right? So we need to split it first. Let's split it using the space delimiter, and this will split the line. Okay, first we need to strip it, because it has the slash at the end. so that's why we need to strip it, so that it can remove that slash, and it will strip it into the word sequence. So we know the first word would be the ID of the audio. Let's say audio ID equal line, and zeroth index would be the audio ID, and line would be, we can say that we need to join it, space join. This function will join all the words. We need to join all the words again, because we want it as a single line. But we don't want the audio ID, so that's why we need to go from the index 1 and then till the end. So this will join all the words, only the transcripts, not the audio ID. This audio ID will have the ID, that means this name only, but this is not a full name of the audio. There you'll see these are the audio files. It has .flsc at the end. This is the format of the audio. So you need to append that with this name. This, since this is a string, you can append it using plus, and then you need to append a root as well. So you can use root plus, but here you need a slash, so that's why I have given 2 pluses. So this is the audio ID. You can use OS function. Let's say OS dot path. You need to check that if this audio exists or not. If it doesn't exist, then you don't need to worry about it. You can ignore that audio. So this is just for exceptions. os.path.exist. So this function will check if that path is really exist or not. Let's say print exist. Sorry. And then okay, that's fine. So we'll save it once and then run it. So if you see, it is printing exist every time. So that means all the audios are there. So you need to do everything inside this loop, inside this if function only. So if it exists, then we'll process it or process audio. Otherwise, we'll not process it, or will not include it in the manifest. So here you got the line, here you got the audio ID. Now we need to create the manifest, the output file. Okay, one is recording file, other one is supervision. Recording file will have the information of the audio, and supervision file will have the information of the transcript. Let's open these files first. Let's open it. Open, and then first you need to provide the language, what language you are going to use, and then recordings. This recording should be there, recordings, and then dataset type. The format would be JSON L. So we need to open it in right and as REC, and then we need to do this for the supervision as well. Let's say sup, and this name would be supervisions, and then the rest would be same, and everything should be inside this with. And here we have opened 2 files in this directory, wherever the script is there. And after that we need to calculate the duration of the audio, but before that we need to open the audio first, and for that we can use torch audio. For that we need to import torch audio, and we know this is the audio path, so we can use let's say it will return audio information. So let's name it audio info, then torch audio dot info, and then we'll get the audio path. So what this will return, this will have some information of the audio. We can print it here, audio info, and then let's exit it here first. Only one iteration will be there. Okay, so here if you see, it has printed this information, metadata. It has the sampling rate, number of frames, number of channel, bits per sample, and encoding. let's say audio duration. This would be audio info dot number of frames divided by audio info sample rate. So if you print the audio duration, this will give us the audio duration in seconds. So if you see, the audio is 13 second long. And now we can define the structure. This is the structure of the manifest files. Let's comment out those print functions. Okay, so here we source type would be file, and channel would be only one, so it has a list of 0. And then the source would be the audio id, sorry, audio id is the path you need to give here. And then here you need to give unique id audio path, and audio path would be this one, and audio id would be the index of 0. And this audio id we will use that. This audio path would go here, and this audio id we will use in this id. Okay, we got it here. And sources would be this type data, and the sampling rate would be audio info dot sample rate. Number of samples would be this number of samples. Then audio duration is this one, we can give it here. And then this is for the supervision data. This is for recording data. And here the supervision comes. Here we can use the same id, this audio id, and we can paste it here. Recording id is the same one, so we can paste it here as well. Then the audio duration comes, this one, we can use it here. So to dump this dataset, we need JSON. We need to import JSON, and then we need to do JSON dot dump. The data would be the recording data. We need to give the recording data, and this will go into the recording file. Ensure there is a flag, ensure ASCII, you can make it false. So this dataset will be one single line, and then you need to put one /n after that, because otherwise all the recordings will be in single line, and that will not be human readable properly. So you need to write /n at the end of each JSON. So this same thing you need to do for supervision as well. Here I have copied and pasted here. This is the supervision data. Use that, and this is the output file. You use it here, and this is here. We need to give the audio path instead of the audio id. I changed it earlier, but I forgot to change it here. Now I have changed it, and then we can use TQDM as well to see the process, what are the data has been processed yet. Let's use that from TQDM, import TQDM, and then we can put it here, TQDM, and then that's it. Okay, let's run it once. Let's see the output. Here, as you can see, the two files got generated. Let's open the recording file. If you see, it has the JSON in single lines. If you analyze one line, it has the individual IDs for each audio. Sources would be whatever we have given. This has the path, and then after that it has the sampling rate, number of samples, audio duration, and channel IDs. These are the things you need to train the model. And Similarly here, if you see the IDs here, and then recording IDs would be the same, and then starting and ending, these are the duration starting and ending. If you want to start from a different point rather than 0, then you can use it, you can change it here. But for now, since we are going to use the whole audio from the initial point, here we have given 0, and then the duration is there, channel is 0, and then the text. These are the supervisions. And this dataset is mostly clean, so you don't need to clean much. In later part we will see the data, but in this video I just wanted to cover only the data preparation part. Yeah, so this is it. We have prepared the manifest, and now what we need to do is we need to create a folder in this data folder. Let's use mkdir, and the folder's name would be manifests. And then you need to move these two files. Let's use mv and en recordings, and en supervisions to manifest. So we have moved it to manifest, and then if you open this folder, sorry, what happened, it's not refreshed. If you open the manifest folder, here you will find these two files. What we can do, we can separate out some data from this training for validation set. Let's go into the manifest, and then just give me a moment. It is not visible for you, I think. Yeah, I'm in manifest now. If you do ll, you will find these two files. So let's take the tail of each file, and number would be, let's say, how many, 200, and en recordings, and we will put it in a en file recording, and then we'll change this train to test. Okay, and if you do ll again, you can see it has this test file, and then you can do the same for the supervisions, en supervisions, and then en supervisions, and then we'll change this train to test. Okay, now if you see there are four files, and if you count these lines, if you do wc minus l and then star, you can see these two test files has 200 lines, and then others has 28,000, and then similarly in the supervision also 28,000 files are there. So these are the audio files that we are going to use in the training process. So this is it in this video, and in the next video we will start the feature extraction. We'll go into the feature extraction. I'll explain what is feature extraction, and what kind of features we are going to use in this training process. After that, we'll dive into the training of the model. Stay tuned.